Next, let's briefly introduce some common and famous virtual reality applications in healthcare. The first kind of application is medical education. We can use VR system to teach anatomy. Actually, we can use 3D visualization techniques to visualize or render massive volumes of information and databases. For example, we can use such a system to explore the organs by flying around, behind, or even inside the. Okay. In such a system, clinicians and students can understand important physiological principles or basic anatomy. Such a system or tool can be used as both didactic and experiential educational tools, allowing a deeper understanding of the interrelationship of anatomical structures that cannot be achieved by any other means or tools. For example, the cadaveric dissection. One of the famous medical education tools to teach anatomy is the Visible Human Project. Visible Human Project. This project is started in August of 1991 by the University of Colorado School of Medicine. There are two datasets, okay? The female dataset, okay, has more than 5,000 digital anatomical images obtained at 0.33 millimeter intervals. The total volume of the female dataset is around 39 gigabyte. The male dataset has around 2,000 digital actual anatomical images obtained at 1 millimeter intervals. Okay, the total volume of the male dataset is around 15 gigabyte. There is also a toolkit of computational programs capable of automatically performing data handling functions required for using visible human data in applications. Okay. The researchers also provide VR dynamic models to illustrate how organs and systems move during normal or diseased states, or how they respond to various externally applied forces. For example, the touch of a scalpel. Later, China also kicked off a Visible Human project named as Chinese Visible Human Project. Actually, as you know, I obtained my PhD degree from the Department of Computer Science and Engineering, the Chinese University of Hong Kong, CUHK. In my previous lab in CUHK, okay, we developed a set of visualization and rendering algorithms and tools to visualize and render the visible human datasets. Okay, both American visible human datasets and the Chinese visible human datasets. Totally, we visualize and render 7 sets of human datasets. Okay. I can show you some demos, okay, when we resume the face-to-face teaching in my next lecture, okay. The next very commonly used and famous application of VR in healthcare is surgical simulation for surgical training. As we know, for surgical training, there is no alternative to hands-on practice. Hands-on practice is very important for surgical training. Traditionally, there are 3 platforms and methods to train new surgeons, including cadavers and phantoms. Second, animals, or directly training on patients. But all of these training paradigms have shortcomings. First, the cadavers and phantoms have no dynamic responses to surgical operations, so it is not a good training platform. Animals have different anatomical structures than human beings. If we directly training on patients, okay, any small or teeny error may do great harm to patients. So all of this have obvious shortcomings and not training good training platforms. On the other hand, virtual reality-based surgical simulation can address the above-mentioned challenges and problems because they can provide realistic anatomical surgical environment with realistic interaction between the human organs and the virtual surgical instruments, enabling the new surgeons to practice the surgical skills in a virtual world, okay, in an effective, realistic, and safe environment. The next common and useful application is neuropsychological assessment and rehabilitation. Okay, there is a prediction stated in 2002. Okay, stated in 2002. Use of VR and computerized therapies are ranked respectively third and fifth out of 38 psychotherapy interventions will increase in the next 10 years. Nowadays, the prediction become true. Okay, VR has been widely used in neuropsychological assessment and rehabilitation. Specifically, VR is used to simulate the real world and to assure full control of all the parameters in neuropsychological assessment and rehabilitation. First, a wide variety of procedures of interventions on psychological distress can be programmed in VR system. And second, we can structure a large amount of controlled stimuli and monitor the possible responses generated by the users of the virtual world. And therefore, we can increase the therapeutic effectiveness in neuropsychological assessment and rehabilitation.